Good morning, Math Masters and Math Wizards. Time for Eureka Math in the Morning with the one and only Mr. Leggett. Miss you all very much and can't wait to see you next school year. Today we are going to continue subtracting a fraction from a mixed number. I'm going to look at it a new way to do this, yet another way. And let's start out with 3 1/8 minus 3/8. Okay. What we're going to do is we're going to decompose this to 2 1/8. And what else do I need? Well, it's 3 1/8, so I need a 1 over here. So I have 2 1/8 and 1. What is this going to equal? Well, we're going to flip this around now and do some addition. 2 1/8 plus, what do we think we need to add to this? It's kind of interesting. Let's think about it. Well, we need to make this 1. How would we do that? We would add on 5/8, right? Because 3/8 plus 5/8 is 1 whole, and we took away that 1. So now we're ready to add, and we get 2 and what? 1 plus 5 is 6. The 8 remains the same, so we get 2 and 6/8. Now, let's prove this by using a number line to see what we did, okay? We're dealing in units of 8, so we have 2 here, 3 here, and I'm going to put a 4 over here. And let's break these down into 8s. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Where do we start out at? We start out at 3 1/8, okay? And now, just thinking we just subtracted the 3/8. 1, 2, 3. We'd be at 2 6/8, right? But the way that we approach this, and let's go ahead and do that right now. 1, 2, 3. Whoop. So we did minus 3/8. But when we decomposed it this way, what we did is we went all the way back. We got rid of that 1 and we went to 2 1/8, right? Excuse me. Pardon me. So that's minus 1, right? But then we added on the 5/8. 1, 2, 3, 4, 5. So we wound up at 2 6/8, correct? Yeah. This is just another approach to do, is to break it up like that, taking away the 1, and then adding on the fractions here to make that 1 whole. So we took away 1, but then we added the 5/8 on there. Okay? Kind of getting that? I'm sure you will. Let's try another one. And the next one we're going to tackle is 5 1/8 minus 7/8. Break down the 5 first. So we have a 4 1/8 and 1. We're going to get rid of that 1. So let's do 4 1/8. We're going to add now. We need to add the remainder here from 1 subtracting this. Would be what? Be 1/8. You need 1 1/8 more to make a whole. So plus 1/8. And what's our answer? We have 4 and 1 plus 1 is 2. 4 2/8. And there we have that. Let's prove it. Maybe we could prove this one. Now let's go use the number line. I find that to be a pretty good way to do it. And we're going to start out with 4, 5, and then 6. Let's make 8 units. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. We start out at 5 1/8. I'm going to subtract 1. Whoop. Goes all the way back here, right? But then I'm going to add on another 1/8. Whoop. And I'm right here at 4 1 2/8. There we have it. Just a different way to tackle this. Let's continue on. And we'll do 5 3/5 minus 4/5. 5 3/5 minus 4/5. Okay? Decompose this into 4 3/5 and 1. Right? 4 plus 1 is 5, and there's a 3/5. We go over here. 4 3/5 plus what? How many fifths do I need to make that 1 whole? Just 1, right? plus 1/5. And what will that equal? 4, and 3 plus 1 is 4. And the 5 remains the same. Let's go ahead and make tape diagrams for this one. So I'm going to start with 5 3/5. There's 1, 2, 3, 4, and 5. And I'm going to break this into fifths. 1, 2, 3, 4, and 5. 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 Okay? So what we're doing is we're making 5 3/5. I'm going to just shade these in really quickly to show 1 hole, 2 hole, 3 holes, 4 holes, 5 holes, and Mr. Leggett forgot something. What did he forget? He forgot the 3/5. Let's put that in there. And we'll put in 3/5. 1, 2, and 3. So now I could subtract the 4/5. 1, 2, 3, 4, and wind up with 4 and 4/5. But the way we went around it is we subtracted 1. So all of a sudden we had 4 and 3/5, but then we added on the other fifth, and look what we get, 4 and 4/5. So I can just subtract those 4/5. 1, 2, 3, 4. 4 holes and 4/5. Okay? Let's try the next one and maybe kind of do it kind of quickly, almost in our mind. Oops, Mr. Leggett owes a marble. And here we go. We're going to do 6 and 4/12 minus 7/12. Let's see if we can just do this really quickly, okay, without thinking about it, without drawing tape diagrams or number lines. I'm going to subtract 1 from here. So this will become 5 and 4/12. I'm going to add. How many twelfths do I need to get to 1, 7, 8, 9, 10, 11, 12? I'm going to add 5 twelfths. So what's my answer going to be? Well, 4 plus 5 is 9, right? 12 remains the same, and bring the 5 over. It's 5 and 9/12. Believe it or not. Don't believe me? Well, let's go ahead and do the number line. I heard someone doubting me out there. And we'll go 5 and 6 and 7. We'll break them into 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm at 6 and 4/12. 1, 2, 3, 4. I'm subtracting 7/12. 1, 2, 3, 4, 5, 6, 7. Boop. Where am I at? I'm at 5 and 1, 2, 3, 4, 5, 6, 7, 8, 9/12. So we can do this, and we're going to practice some more on this Tuesday, and we'll get this down, and soon maybe we could just start doing these really quick in our head. Wouldn't that be something else? Some mental math. I hope you have a great weekend. Make sure to do the language arts lesson and log on to Imagine Learning, Imagine Reading, and do some Zern if you like, IXL, all that good stuff, you long distance learners. And I will see you Tuesday. No, excuse me, Monday. It's not a holiday. I'll see you Monday. Bye for now.